The ISO 3382 Part 3 standard for open plan offices specifies single number quantities that indicate the acoustic performance of an open plan office. Measurements are made at multiple positions, and 4 quantities need to be measured at each position. The sound pressure level of pink noise, LPLS, the full speech transmission index, the background noise level, LPB, and the source receiver distance. In DIRAC 6, these 4 quantities can be measured simultaneously using an intermittent stimulus. For ISO 3382 Part 3 measurements, this is a 10-second pink MLS or E-sweep followed by a 10-second silence to capture the background noise. The omnidirectional source needs to be calibrated, which should preferably take place in a reverberation chamber, although a free field calibration will also suffice. For the system calibration, you use the same equipment that you will eventually use for the office measurements, and you need to use the same basic stimulus, E-sweep or MLS, and receiver configuration. First, in the reverberation chamber, measure at a number of different microphone positions. Then, in DIRAC, select Calibrate System from the Setup menu and select the files you just measured. For reverberation chamber measurements, you select Diffuse Field and enter the chamber volume. Enter a descriptive calibration name and click OK. Now, in the measurement window, we can find the system calibration on the Gain tab. For a free field calibration measurement, use 5 angular rotations of the source. When you open one of the measurements, you can see the arrival time of the first reflections. This determines the time window to use for the calibration. In this specific case, a 5 millisecond window will suffice. Then, in DIRAC, you select Calibrate System from the Setup menu and select the files you just measured. For free field measurements, select Free Field and enter the time window you just determined. Enter a descriptive calibration name and click OK. Now, in the measurement window, you can find the system calibration on the Gain tab. Note that you only need to perform a system calibration once, as long as you keep using the same equipment and the same measurement setup. Also, it is possible, though not recommended, to perform a system calibration after the office measurements are done. For the office measurements, use the same setup, but in addition select the intermittent option to get accurate background noise levels. You can also load the ISO 3382 Part 3 preset. First, you need to perform a level calibration. Insert the microphone into the calibrator and start the calibration on the Gain tab. Enter the calibrate again here and use the default name for the new level calibration. Now perform measurements at different workstations with different distances from the source. The requested quantities can be summarized in two graphs. The first is the A-weighted sound pressure level of speech versus the source receiver distance. The regression line in this graph is used to calculate the A-weighted sound pressure level of speech at 4 meters and its spatial decay rate. The second graph shows the speech transmission index versus the source receiver distance. From this graph we can read the STI at the nearest workstation. The distraction distance is the point at which the STI reaches 0.5 and the privacy distance is the point at which it reaches 0.2. Both are calculated using a regression line through the STI measurements. The average A-weighted background noise can be found by displaying the LAEQ of the second channel. Of course, the graphs and the calculated single number quantities can be saved and printed.